So now we're going to be setting up our own equations and solving them, okay? So the only different part of this section, 2.5, is that, well, the part that's the same is we'll have equations to solve, and you guys are getting a lot better at that, so that part shouldn't be too bad. But now what we have to work out is now reading a problem and setting up an equation, okay? And you've heard of let statements, yes or no? No. Okay, so if you're going to use a model a real-world situation and use a variable to represent something, you know, that changes. Right, yes, that's what I like to do. But generally, you want to tell whoever might be reading it what your variable is. You know, if you're going to use x, let x be the number of, I don't know, whatever, hours you work. You'll say let x equal hours, right? That way someone will know I'm reading it. I mean, I would use an h to make sense to me, okay? Well, they have all this stuff. I don't want to go through all this. They said use a let statement and translate stuff. So we did some translating things into expressions a while back, right?
Yeah.
3 times the numbers, 2, all that. So kind of you do some of that, but now we're going to have equations with it. So let's look at this first one, okay? The sum of it, okay, sum means to do what? Add, okay. Of a number, the sum of a number and what? 5 more than the number is, mathematically, for the word is, what symbol are we going to equals, and on the right of the equals will be what? Okay, 17. Part A, first experiment. No, we're not going to waste our time. We're just going to set this up, okay? So we need a variable for the number. What do you want to use? N? So let's get, I mean, this is a really simple case, but when they get more complex, you definitely want a let statement, especially if you have more than one variable, right? So let's just say let N equal the number, bless you. Now, is there something else in there? What are we going to be adding to the number? 5 more than the number. Not 5, 5 more than the number. So how do we represent 5 more than our number when our number is n? That's 5 times. 5 more than. N plus 5, right? That's 5 more than, well, I'm going to write it all out. Okay? 5 more than. So we want the sum of a number and 5 more than the number. So what do we write there, children? We're adding 2 things together. What are the 2 things we're adding? N and
5.
Not 5. N plus 5. We're adding the number and this entire 5 more than the number. Technically, yes. But it won't make any difference here because we're adding it. If we were subtracting it, it would. But that's a good question. So what do we write, guys? N plus, not 5. That's, yeah, N plus 5. So this is the sum of a number and 5 more than the number, okay? Equals 17. Some of you just wanted to write N plus 5 equals 17.
Oh, I understand this now. I wasn't understanding when you wrote it down.
Now you see it now? So this is the sum of a number, right? And 5 more than the number. Not just the sum of a number and 5, right? You all were trying to write the sum of a number and 5. This is the sum of a number and 5 more than the number. You with me? Okay. Get rid of that stuff. So now, if you set it up, solving this now, you asked about parentheses, right? Just technically, yeah, you would, right? But what's in front of the parentheses here? Positive 1. And when I distribute through 1, does it change anything? If it was minus that, then by God, you better have parentheses, because that will change everything. You have a question? Combine like terms. What do we get? 2n
1 plus 5 equals 17.
equals 17. Subtract 5 from both sides.
And you get n equals 6.
We get, well, first we get 2n equals 12, right? The number is 6. Checking, I don't like, in middle school they made you check everything you did. I don't need you. I would say it's a good idea though, like when you're on your own, you don't know if you got the right answer. One way to find out, go back and plug it in and see. Just think of it this way. Here's the number. What's 5 more than the number? 11. Do 6 and 11 add to 17? Where's your check? Okay? What? I just did the check for you by thinking it through. Okay. Now, you asked about parentheses. And we're going to need to think about that with this one. So read this one over. The difference. What operation does that mean, difference? Okay. Between what? No. Twice a number. 2n. And what?
And a number that is 5 more than 3.
No. That is, read carefully. That is 5 more than it. It being the number. Why? 5 more than it. Okay. So we want to do let n equal the number? Uh-huh. So the difference between a number, twice a number. So how do we write twice a number? Okay, 2n, and it says difference, so what? Minus what? N plus 5. Well, hang on. Is 3, so equals 3. Okay. Now, is this correct? Okay, because it's the difference between twice the number and this entire number that's 5 more than it. All we're subtracting here is the number again, and the 5 just gets tacked on. So I need what?
Parentheses.
We need parentheses, because now it makes a difference, because what's in front of the parentheses now? A negative 1, right? So this is critical here. It'll change everything. So what do we do now? 2n minus n, no, minus 5 equals 3.
So it could just be n minus 5.
Equals 3. Then you add 5. And you get n equals 8. Oh, but they didn't ask us to solve it. Well. So then what is so their test,
Number 4.
your parentheses thing? It is number 4. Choice 4, yeah. Okay? You good? Okay. All right, let's go to the next page.
This actually isn't all that hard today.
Good. Okay, we have an age problem. So we have Evie and her father comparing ages, because that's what kids and parents sit around and do. Yeah, I guess. At the current time, so right now, what does it say about Evie's father's age? Okay, then, yes. So last period, everyone was trying to tell me, because you guys don't like to read carefully, their father's 36 years old. It's like you saw words that made sense initially to you, and you stopped right there reading.
So what is our?
He's 36 years older than she is now.
Would
Okay?
it be 36 plus 5 times her age?
Hold on. Oh, could be. Could be. Hang on. We got to read this. Okay? So Evie's father, 36 older than her. 3 years from now. Let me ask you a question. What do you want to let stand for Evie's age? I'm going to, why do they keep, I'm not going to do that. So let's go down to B. Let E equal EV's, is it IE? Age now. Right now. Okay? And then, how do we represent her father? If he's 36 years older than her, he is her age. He's 36 years older than her age, E. So how do we write that? E plus 36 equals father's age. Now I have a question for you. In 3 years, if Evie is E years old, how old will she be?
30.
She'll be 3 in 3 years?
12, 6.
How do you know we don't know her age now, so we can say.
No.
Her current age is E. E plus 3.
For E. That's it.
So 30 basically.
No, that's 3 times E. E plus 3. Now let me ask you a question. Currently, her father is 36 years older than her. In 3 years, how much older than her will he be?
39.
5.
Think about that. He's currently 36 years older than her. Forget the 5 times. I'm not even reading the rest of the problem. He's currently 36 years older than her. In 3 years, how much older than her will he be?
Plus
36. Still. Won't he always be 36 years older than EB?
Oh!
Aha! See, I got you on that one. Okay. Well, somebody caught it here. Yeah. Okay, so I want to get that out. Now let's go back up to the problem. Up here. 3 years from now. Okay, so EB, we agree, will be what? E plus 3, right? And also, her father will be 5 times her age at that point. How old is Evie? So let's just say, okay, so let's do 3 years from now. Okay? So Evie's no longer E years old. How old is she? 3? Why do you guys keep doing multiplication? E plus 3 equals, her father will be what?
36.
36 years older than E, right? Won't he be?
Yeah. Going to be E plus 36.
Oh yeah, let's do her. Yeah, let's do it. Yeah, we should start with the father. I'm sorry, scratch that. I'm sorry. I got you. So her father is E plus 36, right? So in 3 years, he will be her current age plus 36 plus another 3, right? And we're putting the plus 3 in here, but that's because her age is going to be plus 3 as well. So he's still 36 years older. Okay, equals, and it says what? 5 times her age at that point, which is the E plus 3. So what do we write? 5 times E plus 3. Is that right? Is that right? Is this right here? Is that right? What? No. Did I write this correctly? What am I missing? It's 5 times her current. This is only 5 times her age back then.
Can you put parentheses around the E and put 3?
Yes. The whole entire current age. Thank you. That's what we're getting at. Okay? Okay. Now we can solve it, can't we? For Evie's age, what do we do? What do we get here?
E plus 3.
Equals what?
5.
Plus 15. Wonderful. We got variables on both sides. What should we do?
We should move 5. We should move the E.
Yeah, and I like to have my variables on the left, right? So what are we going to do? minus 5e here, minus 5e. Now, you guys are getting comfortable with this. After this, what are we going to have to do? Subtract 39 from both sides, right? Can we just wrap that all into one step? Instead of doing it so, can I just do this? Because I know I got to do it eventually. Does this bother anybody? Do all this at the same time? Did I lose anybody? Because I'm combining what we have normally been doing in 2 steps into just one. Because you only have to do it anyway, right? I'm not saying you have to do this. Maybe when you get comfortable with this. Save the time.
Blah, 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 blah. I can't speak.
Go ahead.
Since we're subtracting 5e from the regular e, wouldn't it end up being 5e?
No.
That's 1e.
4e.
Minus 5 of them is not 4.
Negative 4e.
Okay, so we end up getting negative 4e. The 39 went away, right? 5e, and then 15 minus 39 equals negative 24. Now finally, what do we do?
Divide each side by negative 4.
By negative 4.
E equals...
No, not negative. So EB is 6 years old. Okay? Yeah. But,
Can I go back?
Yeah.
How much you need to pass?
go ahead. All right. So this, I mean, if you guys would like to do this, you know you're going to do in the very next step, you can go ahead and handle it in one like that if you're comfortable with it. Okay? That's fine with me. Okay. This next one. It's going to get a little bit confusing. Read that over. Kurt, step 12. Read it over. Recording the whole time? Okay, anyway. So, let's get on to, geez, I skipped a lot of this in the recording. Anyway, for those who are going to watch this later, I guess I forgot to hit the record button after I pause. Here's our answers to some of these. This isn't for you guys. We skipped that one. I don't remember where I paused. Here's the answers of 2 and 3 and 4 and 5. Okay. It's weird to do that. But anyway, so let's read number 7. Mike gets paid weekly. Mike gets paid weekly, represented by 2.5A plus 290. So he's selling cell phone accessories himself, right? So let's think about this. Commission means you get more money for every phone you sell, right? So what part of this expression would represent his commission? Well, of the expression, 2.5A plus 290. Which term, this one or this one, would represent his commission? A, yeah, 2.5A. A being probably the number of cell phones he sells, right, or whatever it is, okay? You guys know what a constant term is? It's constant, it doesn't change, there's no variable. So what part is the constant term? 290. The 2.5A changes, it's variable term, because plug in different A, different, right? So what do you think that constant term is? Yeah, and some commission jobs, they do give you, no matter whether you sell anything or not, just for showing up, they'll pay you a certain amount. And then on top of that, you can earn more, like per thing you sell, right? So you guys would agree then that the answer to this is choice 3. So if he doesn't sell a single cell phone, they'll still pay him $290. Probably not for long. Probably won't give him too many more weeks of not selling any cell phones. Right? Tell him it's been good to know you. All right. There we go. Now we got to get a little bit of math in here. 2 parking garages. Read that over. They both have different cost structures. And there's one thing in here that is going to be a twist to it. It's going to be tough to understand at first, but then you'll get it. So read that over. So I have garage A, garage B. You see they have different cost structures per hour? Yeah? Slightly different? So we'll want some, part A is going to ask us to write equations. So garage A charges $7 for the first 2 hours. So 2 hours is a flat $7, right? And then what does garage A do? Every hour after that is $3, okay? Now, they're telling us what to use for the number of hours, and that is what? So we can't really pick our own variable. Like I would normally want to use H here, but in this Regents question, yeah, so, and that's important. If the Regents question tells you to use X for hours, you got to use that or you lose points. Okay? I don't care for it, right? So let's think about modeling garage A's charge, and then we'll do B. B's pretty simple. So garage A, $7 parked for the first 2 hours. All right? That'll never change, right? Okay. And then every hour after that costs how much? $3. So we have a constant amount and a rate of change, like a starting point or MX plus B, right? Okay, so A is going to be $7 plus what? 3 times the number of hours. Okay. All right, hold on. Think about this for a minute. We're close. Yes, ma'am. It doesn't, right? Commutative property doesn't. Yeah. It would, yeah. Like MX plus B for MX plus B, yes. But I thought in this case it was easier to start with the 7, and I think it'll kind of help explain this. Okay, let me ask you a question. So $7 for the first 2 hours, and then every hour after that is $3 for every hour after that. I mean, if you parked your car there for 10 hours, you're going to pay that $7 plus $3 time. Wait a minute. The first 2 hours are already taken care of here. No, the first 2 hours are taken care of here. So you're not multiplying 3 times 10. It would be 3 times what? 8. Okay. If you park for 6 hours, it would be 3 times what? Because the first 2 hours, 4. In other words, how much less than the total number of hours? Because of these X hours, 2 of them are accounted for with the $7. You follow me? So it's not 3 times all of the hours. It's 3 times the number of hours, what? You said it. Minus 2. You get that? Let's sink in for a second.
Sure.
You pay $7, and that accounts for the first, if X is all the hours you sat there, you paying $7 for the first 2, then what's left you pay $3. So this is a little tricky to think, right? So if X is the total hours you're there, there's 2 of them, and it's $3 times the rest of them. So if you park for 15 hours, it would be 3 times what? 13. Okay. Does that, you kind of get that now? Oh, you got to be careful with those. All right, so garage B is quite a bit simpler, right? Give me the model for garage B. 3.25x, it's right? There's no 2-hour thing, right? Okay. Now, part B is a little like the question in the homework last night. Read part B. What are we going to do? Okay, so here's the cost for garage A, cost for garage B. In math, when we want things to be the same, what do we put between them? Then we have an equation, and you solve it. Okay? In this case, we'll solve it for the number of hours. So give me an equation. I'm going to leave with the 3.25x. You're not wrong. I just had that in my head already. Okay, garage B cost needs to what? Equal, garage A's got 7 plus 3 times x minus 2. Okay? So that's the expression for each garage parking cost. And we want to find out how many hours it takes for them to have the same cost. So you set them equal and solve for the number of hours x. Now you guys can do that, right? Right? You know what to do. What are you going to do? Yep. So we got keep this. equals 7 plus what? Minus 6, right? Now what do you want to do? That's right. 0.25x equals, let's lead with the 3x, what? Yep, plus 1. What are we going to do now? Yep. Let's move this. I almost said move it. Let's subtract it from both sides. All right? And what do we get? 0.25x equals 1. And finally what? Can't be lost here. It's the same as always. What do we do? By? Huh?
One.
Number 5.
Divide by 0.25.
Oh. I didn't see the
And what is 1 divided by 0.25? 1 divided by 0.25. In other words, how many times is 0.25 going to 1?
one.
Really? How many times is a quarter going to a dollar?
Oh, 4.
Or you do on your calculator, do 1 divided by 0.25. What do you get?
4.
Just confirm it. On your calculator, but 1 divided by 0.25. This is one of those cases where you divide, you get a bigger result. Usually you get a smaller number, right?
Yes, 4.
Did you all get 4 on your calculator? Okay? I think that was the last one, wasn't it? All right.